Okay. Yeah. Thank you for everyone joining the call. Uh, my name is Suresh Kankanwadi. I'm the technical manager. And today the workshop is on the Fusion 360 for to the manufacturing extension. The especially today I'm going to cover onto the manufacturing extension, the how the benefit and what are the tool path can use for to the manufacturing extension. Basically, I'm going to cover for the different projects for to the different options on to need to understand the capability of the Fusion 360 extension, especially for the machining extension. Okay. On that hope, we'll start for the first section. And today the agenda was you can see the agenda was to cover onto the introduction of the power, like what are the manufacturing extension on the Fusion 360 and covering onto the design a little bit, not on the much deeper. Just I need to understand a little bit onto the design side, going to explain onto the what are the tools available. Then more onto the capability of the Fusion 3 extension and as well as to the CAD for manufacturing on mainly covering onto the 3 and 5 axis toolpath onto the milling side and as well as to the whole recognition, turning and turn mill inspection. These are all the options is covering. Then we will take the Q&A onto the end of the section, or maybe in between you have any questions or anything, you can chat me onto the chart. Then just we'll take on that questions and we will discuss onto the end of my presentation on any questions or anything. I hope this is the agenda to set it onto the another one, like a 2 hour section. In between, we will take some break and we will continue on to the after break. Okay, first one is like a Fusion 360 is for to the designing and engineering. It will support for to the parametric model. Basically, it will more onto the CAD side, like it will support for the parametric as well as the surface modeling. And you can do the direct modeling the whenever you want to do the Boolean operations like a cutout and hole and pockets and all. Then the PPOM surfaces, the any kind of the preform surfaces can possible to do it for the surface modeling. And most important, it will support for to the sheet metal and as well as the mesh modeling. These are all the capability of the designing side. And let's understand from to the details like a surface modeling. Basically the surface modeling is to like a bridge gap between to the concept design and the functional surface, the wherever the surface designs you want to do onto the modeling side, then we can do the surface modeling. Then it is any flexible to change it, the any kind of the surface can change very flexible because of the parametric. That is the main advantage of the surface modeling here. And easy to creation and the control, it is quickly you can control your surface, and it is in a faster learning curve because of the lot of the tutorials is available onto the then it is in a what is the capabilities like a traditional parametric surface, what I told on to the before. It is in a parametric surface modeling to give the dimensions, and wherever your dimension is updating on the parametric way, it is going to control onto the parametric basis onto the surface modeling. Then the parametric modeling part to the solids, the whenever you are doing the solid modeling and these are the parametric solid modeling. It is a common engineering method when you are doing for the parametric methods, and it is a collaborative product development. Whenever you are doing the some group kind of the teams, like you want to do the collaborative, the parametric, wherever you are the drawing or changes on the somewhere else, then it is automatically updating onto the previous version or the latest version. Then the easy to track the changes, then as well as to the reuse for the design data whenever you are going to use that, because of it is going to cloud save. Then whenever you want to refer that particular drawing, then it is any then it is any capability for the 2D and 3D sketches, then the part assembly designs as well as to the sheet metal and surface and drawing. These are all the capability onto the part modeling, like with the parametric modeling. And direct and mesh modeling, you can able to do the direct modeling with the no feature construction is not required. You can directly make a holes and other features directly onto the model without the construction also. Also it is a quickly heal imported model. It is possible to modify or to the repair with the imported model onto the. And also it is capable to import the 50 plus files. It is called as any CAD file. It is possible to import and edit and repair imported geometry. The what are the geometry you are imported, it is possible to edit and repair. And import the scan and mesh model. This is the important the options as put to the mesh modeling. The any kind of the scan model is called as the STL model. It is possible to import onto the inside Fusion 360. And documentation, this is the last option for to the designing, or like any kind of 2D documentation can do it onto the designing, like you want to do for to the 2D drawing conversion. And one more the good advantage on this one, like whenever they were drawing 3D model was changes, then it is automatically updated onto your 2D drawings. That is the major use of to the documentation purpose, and there is no lag between the 3D model to the 2D models. Okay, let's come on to the benefited for the integrated CAD CAM software when you are doing the parametric work holding design, designs or anything, and it is possible to import and do the use for that work holding devices onto the machining. Sorry, whenever you want to changes your work holding devices, and then the cam space also is going to export. Sorry. Then the analysis tool is available on that. You can do the analysis, and as well as the surface modeling for the tool path. Any you want to use some surface tool path, you want to extract the surface from the model, it is possible to extract. Okay. On that, today coming on to the agenda, to just I'll cover some few few option onto the turning. This is coming on to the base fusion, but after that, what are the section I'm going to cover on next? But the entire the section is on the extension, but I just need to show on the some basic 2D kind of the operations, the how we can do onto the turning, as well as the what all the operations are available onto the turning. Let's us move on to the software side, the how the software will going to perform onto the turning side. Okay, this is the model was imported onto the turning, and you can see now it is possible to hold the model or the component onto the check. You can import this check, or maybe you can create the check in the using the modeling design in the design space. The then you can take into the manufacturing. Once you click onto the manufacturing space, and after this go to the setup, and it is possible to set onto the setup. Just to click onto the setup, and the setup was creating, like you can see here, the jet is showing onto the opposite direction. You want to flip into the jet, just to click onto the flip into the jet. Now you can see the jet is placed onto the this side, and you want to change the where the jet you want to set, or maybe you want to set the safe X and Y, as well as the bottom of the check. Suppose I want to save into the model, you can set into the model the which model you are going to machine. You can select and you can set the model. Once you set it, and also you can go to the like a setup, like a stock print or the safe height, and also you can able to see the details the what is doing. Okay, you want to change this drag, like you can possible to drag it to set up your the check backside, the how much from the raw material you want to turn, or the that all it is possible to set it here, or maybe you can select here the save jet option. Then it is possible to set the stock the according to your stock materials. And possible once you set these options, then you can go for the toolpath. For the facing, you want to do the facing toolpath, just to simply select the facing toolpath, and it is going to generate the toolpath onto the facing onto the front of the model. And because of the tool was selected here on the previous operations, and it is possible to select the tool for to the turning. Just to click on the turning, these are all the basic turning tools are available. And also it is any different tools are available on to the new tool creations, and these are all the tool like a turning, a general tool, boring and grooving and threading. The other tools are available to generate the new tools. Once you've done, then you can go to here, the set the operations from where you want to start, the how much the stock is there, you want to increase or decrease. This is the stock height. It is considering from the facing and the safe height. Once you've done, then go to the number of passes. You want to add the number of passes, or you want to use only the one finishing passes or the multiple passes. Just to click it here and you can add the step over and all. It is going to take the multiple passes. Uh, Last one is linking, like how the tool is you want to approach from this, and it is possible to approach. And also you want to switch up your the model, like you don't want to see the checks and all. Maybe it is possible to switch up your checks only, you can able to see the 3D model going here, or maybe you want to switch on again. It is possible to just to click and untick onto the things, and you can do it. Okay, on this turning, then after this, you want to generate the toolpath for to the profile turning. Just you simply click on to the profile turning, and it will take into the center section of this one, and it will generate the toolpath for to the profile. Just need to select the geometry from where to where I want to start from here, and then I want to end. Like you want to print to the model print or to the selection or the whatever you want to do it, you can just simply select this one, and then it is in a back one. Back is the where you want to stop your model, or up to where you want to turn the profile. Just to select the front and back option. Then after that, the safe clearance, it is possible to set the safe clearance onto the, then the number of passes, like you want to do the horizontal turning or to the vertical passes. The vertical will do the vertical passes onto the this direction, horizontal will do the this direction passes. Then it is you want to avoid the grooves, or you want to cover the grooves wherever the possible. Allow to the axis groove or to the radial groove you want to allow, or you don't want to allow, just you both you want to allow, just you select this, or you want to don't want to allow, then it is not do any the grooves the whenever the coming into the inside of the profile. Okay, you want to leave any stocks, the after roughing you want to keep some stocks, then you can mention the stocks. Okay, after this, and then you can say calculate the toolpath, and it is going to calculating the toolpath on this particular profile. As it is very simple, the method of calculating the toolpath for to the turning, and you can see now understand the turning. This is the area and this is the top having a stock, and it is not entered any group profiles. Okay, like that, it is possible to select the groove tools because of we are having a groove options here. You can select the grooving strategy, and then we need to identify the where to where you want to do the grooving. Just you simply select onto the here the options, like where you want to from the groove you want to do it from. I want to do the groove from here to here, then you set it the plane from to the front and back. Suppose I'll go to the selection, I want to select this is from here, then I want to select from the back, I want to do the group from here. Once you selected, then you click OK, then now my toolpath will generate only inside this area. Okay, like that, the very simple the turning the operations can perform on this. Uh, then after this, the many options are there, like you want to do the grooving or threading or champering. I'm not covering this all options because of some of the options are very simple to generate the toolpath, and as well as the parting. The after turning, you want to do any kind of the parting operations, you can do it, and the part catching options. On that, moving back to my PPT, let us understand the extension. The what are the extension, and how the options are going to cover onto the extension is the why the extension, like it is and to the especially for to the technology, and also it is covered into the one platform. The what are the options I am going to create the toolpath, it is covering into the one platform, and it is a manufacturing simplification when we turn to the automated workflow, as well as the team collaboration and the time to market. This is a major the involved onto the extension, and also the especially for the why the manufacturing extension. it is an a simplify and automated CAM programming. Whenever you will going to use for the extension, it is an a automated toolpath creations, and as well as to the reducing the programming time, especially when you are going to do the programming time need to spend less when you are going to access for to the extension, and reduce the error, because of sometime you are entering to the manually the details, then the automated recognize will save your time as well as to the error. Okay, someone is doing the annotation. Can you stop your annotation? Okay. And then performance improvement, then also it is an optimized manufacturing workflow. Then like produce to the better quality of the part, to advanced strategy, as well as to the better surface finish and less manual polishing, and the better part can produce onto using the extension. uh, let us understand the next options. Okay, I will just stop my screen. I will share it again because of some of the annotation tool was came here. Okay, I hope you are able to see again my screen back. Anyone can confirm?
Yeah, I can see.
Yeah, okay. Now we'll see the comparison between to the core Fusion 360 and to the manufacturing exchange. The core Fusion 360 will basically cover for to the turning and the 2.5D milling, 3-axis milling, as well as the 3+2 and 4-axis milling, and also it will support for the 5-axis for to the SWAR finishing. And next one will cover for to the manual drilling, the whenever you are doing the drilling, and it will do the for to the manual drilling will support, and inspection will to the only support for to the work offset setting, that is called as work offset probe settings. Extension will cover onto the more like the 3-axis steep and shallow strategy also coming under to the extension. Then additional tool orientation control for to the steep and shallow. Then 4-axis rotary strategy, 5-axis steep and shallow like a automatic collision avoidance. This all coming under to the milling for to the extension, and as well as the drilling. The drilling is the manual drilling will cover onto the base, and the whole recognition options are coming into the advanced options. Then the toolpath editing as a trimming, then the deleting of the passes are most start point that all are coming into the apart from the base fusion. Then the inspection like a probe geometry, then the surface inspection, then the part alignment, these are all coming into the, and now the today is main on to the focus on to this extension, and I'm going to cover this all the options onto the different projects, like for the milling and drilling, toolpath editing and inspection. These are the different project I'm going to cover to explain the better the how the toolpath will support for this. I will take each one of the example I'm going to cover. Okay, moving into the first one options, like 3-axis steep and shallow strategy, additional 2-axis control, and as well as the steep automated collision avoidance option. The what benefit, like you can see once the steep and shallow is imported, and it is possible to track the curve wherever you want, and mention the cut directions, and as well as the passes you want to cover, like a shallow and the steep passes, then the smooth passes is ticked, then you can click OK. Once you click OK, and you can see this all the toolpath was created for the steep and shallow. The apart from this steep and shallow, the what options are going to covered, like the what the advantage onto the fixed direction and the automated direction. This is the difference between the fixed direction and the automated direction. Then the wall, no wall clearance, like you don't want to touch onto the side wall, then the wall is not going to. And this is the smooth toolpath, and to the sharp corner you can see without the smooth toolpath, and which smooth is the sharp. And then the like it is in a cups, the whenever you want to draw the center line on that one, and it is in a cup. This is the basically the steep and shallow. Apart from this, I am going to cover onto the technical side, onto the one of the example importing and going to show you the how the quickly can generate the toolpath using this option. Excuse. Okay. This is the part was imported the after the importing of the part you can go to set and you can set your the basic G54 offset the where you are going to set your work offset. Just to click it and it is going to highlight as to the corner or the center the wherever you want to set your G54 and it is possible to set into the G54 option. Once you set it the G54 then you can define the stock you want to extend the stock or you want to use the rest machining stock as you can set it, then you can set your post processor the what the output. Once I have set it on this 3D also you can see the all the options like you want to do the area clearance roughing, then the art the pocket area clearance. This is adaptive area clearance and the pocket area clearance can do it, and the steep and shallow. These are all the some of the 3D strategy. As the first one, it is possible to generate your roughing toolpath, and you can see in the roughing toolpath also a lot of options are there to control your the toolpaths. First one is to define the boundary or you want to define the full model. It is possible to define as you required onto the depend upon the machining area. Once you define it, then you can go for to the where you want to set your model top. I want to do the machining from here to up to this down because if I don't want to do the machine down, then you can set it your machine top and bottom height. Once you done, then you can go for to the like a diameter where you are use the how much the step over you want to use and the step down you want to use. Then also you want to cut both the direction or only one direction like a climb milling or conventional milling, you can select it. And all the stock leave for to the finishing operations, you can possible to mention the stock leave for the finishing operation. Once you done this one, then it is any linking also very much the options are available onto the linking, like you want to change your the retraction you want to go for full retraction or minimum or the shortest path as the scheme safe and incremental distance, like this is the options are there here to set your the retraction height. Then here having ramp type also having a like a, you want to pre-drill or to the plunge or zigzag profile smooth or helix, so this you can set it as you required for to the entry of the tool path. Okay. Also it is possible to change the angle, then you can calculate the tool path. Once you've done the tool path calculations and right click and simulate the tool path here, like you can go to this tool path and with the solid and you can possible to simulate it. And also you can simulation time you want to set as a tool move or the model move, just you can view as a model then the tool is going to move now or you want to show any spindle or any machines also possible to show you. I'll show you the machine in the later stage. Now also you can see now the tool path is moving and it is not able to showing any cutting or something. Suppose you want to set it that one like I'm going to move here, right click and simulation start. You want to show here the full tool path or do you want to show only the tool position or maybe the previous tool path after or before. This all you can possible to set into the simulation. Then you can go to the information also the what are the axis is moving and all and also you can see the machining time for this particular tool path. I'll just exit this one and I'll go into the main options for the steep and shallow toolpath. You can see now the created the toolpath with the steep and shallow machining. And here having options, once you created the tool, here having options like a shank and holder. Once you click onto the shank and holder, and it will show you the options, or you want to trim your tool path or you want to full away, like you want to go the tool away from wherever the collision is happening. Suppose I will use the trim pull away, then the tool path will not machine wherever the tool is not going to reach, and it will not machine on those areas. And it is going to take away from this one. And or you want to detect the tools, you want to increase the tool, or you want to trim the tool. But these are the three options you can able to set it. Also, you can set the clearance on this particular the tool path. Once you set it this one and go to the options as it is, you can set the pool area machining and all. Then the where you want to machine. Then here the important, like you want to do the both the direction cutting or the single direction, and also you want to use part to the parallel passes like called as raster or the scale up. Okay, you will use the parallel, then you will take as a raster passes. Then it will balance will take into 3D offset. And also you can first priority, you want to do the top first or the steep first, that also you can set it. Then the top will do first, then you'll go to the steep areas. Then also you can set it here the options. When you set it, then the another important option is automatic collision. This will convert into the 5-axis, or maybe the tool is going to tilt. You can see once I will tick these options, and it will going to tilt the options. But presently this toolpath I am not setting these options. I just increase my tool overhang and generating the 3-axis toolpath for the steep and shallow. You can see and go to the simulate it, and it is right click and just going to simulate toolpath and go here, and then you can see the simulate of the toolpath, and you can see now the toolpath was. And also you can see here the it is, you don't want to see on the solid simulation, just to untick this one solid simulation. It will not show you the material remove, only it will show you the toolpath. Now you can see the material removal. This is a single strategy is going to create the toolpath onto the entire area without any um, material left out. Also, you don't want to see the stock, and you can see this is the tool. And also you can see you want to see the tool on particular point, and I can see now the tool is moving on the, now the model is table is moving, and tool is in a constant as the machine. Okay, now I'll set into this one. And also you can see the tool path you want to see on that particular the tool path. Somewhere you want to attach the tool, and it is possible to click and attach the tool on that particular point. Okay, that is also possible to see. This is the steep and shallow toolpath was calculated onto the entire. And also the one more important option, you don't want to do the flat area machining. Okay, and here you having an option to set, you don't want to do the flat area machining onto the ball nose cutters. So using the, just you untick tick these options, then it will automatically avoid the flat area onto the 3D model. The wherever, like you can observe, these are all the flat areas. You can see this. Suppose I will show this tool path having a flat areas. Okay, these flat areas you don't want to run the particular strategy. You want to run the different strategy on the flat areas. Then the very much capable onto the steep and shallow machining to the avoid the flat areas. Just you tick this and you generate the tool path. Then very quickly you will generate the tool path on only the 3D profiles. Okay. On this, next I'll go to the another options, how to convert this the steep and shallow into the automated collision checking. Just simply tick this option as a automated collision checking. And also you can see the once I will tick these options, my tool axis as a vertical only. Once you click onto the vertical, then the smoothing distance, the how much distance you want to tilt the tool to avoid the collision between the holder and the model. Then the smoothing angle is 5 degree. You can change the smoothing angle. And also automatic collision avoidance having a options like a from curve, from point, and this option also you can change it. Now I have changed as a automated and the tool axis as a vertical. Once you done, and the tool path was calculated here, and you can see now you want to see the simulation on that particular tool path. Suppose I will see here on this particular point, you want to see the how the tool is tilting, and you can observe. I will just say the simulation. I'll put onto the tool mode, and whenever it is going down, just I'll make a simulation slower, and you can understand the tool is whenever it is going down, it is automatically tilting the as the automatic collision avoidance I have used. You can see now the tool was tilting here when it is coming onto this side. Okay, you can see the tool is colliding on this particular pocket, and now the tool was tilting here. And also you can see the wherever the tool was tilting, and it is going to cover that particular tool path, and it is not having any collision between the holder to model or maybe the fixtures or something. Okay, I'll just make another simulation. And also you can see the tool path as well as the stock you want to mention. It is possible to mention the stock and as well as the tool. This is the capability of using the steep and shallow machining with the automated tool, and it is doing the machining on that particular area, and it will do. Okay, I hope you understand this particular the steep and shallow machining with the different options. Just I will recap. This one is first one is on particularly on the steep and shallow for to the geometry, and as well as the tool axis is important here. The tool axis as a vertical. I'm not using any other tool axis, and only I am taking the collision avoidance options. Once you tick, and these are all the options are going to highlight here, and it will generate the tool path according to the holder is colliding on that particular options. Okay, this is the very the simple option, and it is a very good options when you want to do the deeper kind of cavity to decrease the tool length, and you want to increase the finish, and as it is going to increase your tool life also. Okay, back into the PPT, the what going to present. And next one is going to cover on to the automated 4-axis rotary strategy with us like these options. I'm going to cover on to the another example the how quickly you can avoid the automatic collision with the 4-axis rotary tool path. Okay, first I will take into the these options like you want to do the tool path onto the this particular area using the 4-axis, and it is possible to cover. And before going to cover that one, uh, the what advantage will get on when you will use the 4-axis rotary, like the automated 4-axis rotary tool path. It is a different style of different geometry, like you can use the spiral, circular, and line. These are the three options are there to cover. Then also it is in a tool offset move into the cutting point whenever the tool is tilting, and get a surface finish. We can achieve the better surface finish than the smoothing of available part to the point distributions, and as well as to the more fluent machining motions. It will continuously the rotary axis is moving. Then automatic collision avoidance, the fully automated collision avoidance with to the wherever the near to coming, it will automatically tilt on that. And start into the technical demonstration, the how the this particular strategy will help for to the 4-axis rotary tool path. Okay, this is the example with the 4-axis rotary toolpath. I want to do the machining. Maybe you have seen this example in the power mill. The how the what is the comparison between the how you can the toolpath can generate onto the fusion also. Just show you on this example. First, I want to use the strategy for to the multi-axis on that we are called as the rotary. Okay, just to select onto the rotary toolpath. The after rotary toolpath, then we need to set my the axis plane here. The according to my axis plane, once you set it the axis plane and the geometry and all, once you gone there, then you can go for to the toolpath for to the roughing. You want to do for this spiral toolpath or the rotary toolpath, we call as the rotary toolpath. And also you can set where to where you want to do the machining. Like I can able to set it my the limitation like a print from the selection from the this point. Then the second is from this point. Once you select, then you can go to the toolpath you want to do for to the one way or two way cutting. Select the both, and here having a three options what I explain onto the PPT, like a spiral, line, and the circular. Suppose I'll use the spiral one. Then here having options, I will not use the automated collision options now. And let us see the how this toolpath is going to show you on to the uh, spiral toolpath. Like just I will select this, and I can go here the simulate the toolpath. Right click and just you see the simulating of the toolpath, and I will not use any stock options, and you can see now my toolpath is going to play here. And whenever it is coming, it is not tilting, or maybe it is not avoiding the collision, because as we can see I have not used any collision avoidance. Maybe it is possible to uh, hit the holder on this particular profile because of not use any collision options. This is not a 100% safer toolpath, and that's why the rotary toolpath can support it with the automated collision avoidance. To clicking these options, like I can just click into the rotary axis, then the automated collision avoidance toolpath with the distance of the smoothing distance of the 36 mm. Okay, once I will go here, and you can see the simulation of this particular toolpath. Right click and the simulate toolpath. Once I will go here, now we can see understand the whenever this tool is coming, and it will automatically tilting the tool nearing on that particular point. You can observe here when it is coming the tool. Now the my holder was tilted. Before this holder was like this tool was not tilted. Now we can see it is tilted the tool according to this parallel to this surface. Okay, and you can see it also, it will take care onto the bottom surface, and also it will take care onto the side surface. Now you can see, observe the tool was rotated, and the it is taking the cut onto the particular area. Okay, this is the advantage whenever you will use the automated tool overhang. Okay, apart from this automated tool overhang, and now I will go into the different strategy. I want to do the steepens this options for to the inside of circular or spiral. I will go for to the uh, linear action. Like I want to do the toolpath for to the state. Okay. This is the rotary, and the here having options called as line. Just I will select inside of the spiral or the circular. I will use the line. Now you can see my toolpath was calculated with the parallel line. And also you can see this is the without collision, and the toolpath was a little bit near to the that holder. This is the toolpath moment will give you on like this, and you can see the tool is not parallel to this particular surface. But I will use the automated tool collision here. Then the toolpath was going to tilting here. Whenever the collision is coming near to that particular area, you can see now the tool was tilted because of, we can see now the tool was tilted to parallel to the surface. That is the difference between the collision options for to the rotary as well as the 4-axis strategy. Okay, going next, like the another example I'm going to cover for to the rotary 4-axis options with onto the advanced options. This is the one another example for to the rotary toolpath. This is the rotary toolpath as in a some of the toolpaths are into the preview mode and it is possible to, it is in a public preview. It is possible to view or some of the internal view like a preview features are there. Just you can possible to enable your the preview features from here. Like you can go to the preferences and the which options are coming into the extension. You can see this symbol is coming into the extension. These are all the options are coming into the extensions, like the deburring strategy as well as to the corner strategy, and also it is the uh, 4-axis and the machine part alignment. These are all the coming into the preview features onto the extension. Apart from that, like I want to see only for to the some of the manufacturing view, like you want to do the deburring and other options are, these are all available for to the base fusion and this is like we call as inside preview feature. And also the one more is this is for to the public preview. This is the public preview features are available, like you want to do the deburring and other strategy other the 2D toolpath. Once you selected this all, maybe this the toolpath will come under to the like first one. I want to do the rotary pocket wrapping. This is the strategy for to the rotary pocket wrapping to do kind of the rotary roughing directly and rotary contour for the finishing. Okay, once you select and you want to do the any kind of the rotary toolpath onto the top of the cylinder, or and it is possible to make the roughing toolpath using the, just I will keep the tool like this, and it is possible to simulate it. Go to here and simulate it. Now we can see this is with the without stock. You want to maintain the stock, and it is possible to add the stock to do the roughing toolpath with the 4-axis rotary strategy. This is a roughing toolpath we done with the 4-axis rotary strategy, and next one is with the another toolpath. This is about the rotary finishing. You want to do the rotary finishing on any kind of the 3D profile or the taper profile, and you can do the finishing of this particular strategy. And you can see this is the roughing, and next one is doing the this taper finishing of this particular. Once you've done and the interesting one is the pocket. You can able to do the pocket roughing using for to the 2D profile options, and you can generate the toolpath for to the this particular 2D profiles and simulate it, and you can see now the roughing was created. And also you can do the rough feature on this particular the profile. That is the toolpath for this wrap features. And also you want to do any kind of the this slot, then it is can use for this particular the options. These are all the 2D pocket features, and this is for to the inside finishing with the bottom finishing profile with the rotary finish, like a profile finish, and you can see it and do it. And also the one more the interesting toolpath strategy is here for to the deburring. This is also in the preview mode. Any sharp corner, it is possible to do the deburring features. Like you can see the all the sharp corner can possible to do the deburring in the single click. just to select and any ball tool or any taper tool, and it is possible to do the deburring. You can see now it is doing for the deburring for all the sharp corners. Okay, once you're done, and also it is possible to see the machine, the how the machines can simulate inside the Fusion 360 simulations, as you see onto the power mill. Like we have options called as the machine tool simulation, and just you switch on to the machine tool options, and it is capable to do the simulation onto the machine tool. Okay, just I will switch on my machines. Maybe here having options to switch on your machines. Give me the okay. That is also options. Before we need to import the machines or need to add the machines, the wherever you want to see the machine tool simulations, and it is possible to add it. And also we need to select the machine tool here. The when you are doing the operations, we need to select the machine tool, as well as we need to give the like you want to add for to the machine type. Whenever you want to do the deburring or any operations, we need to select the 4-axis or 5-axis or the whatever the machine. Then according to it will automatically identify your features, the wherever the features are there for the deburring. And you can see here onto the action. Okay, and just you select here the machine option. Once you select from here, and you can see now you don't want to show the stock model base or something. You want to see only the rotary axis of this machine, and it is possible to see the rotary axis, and you can see the deburring operations or maybe the whatever the 3D operations you are going to. Suppose you want to see complete machines, and it is possible to see the complete machine. This is the Haas machines, and the 4-axis table was mounted on the top of this one. And you can see now. Also, you want to see the slower movement of the rotary, and you can make a simulations. This is you can see with the ball nose, and it is doing the deburring option. Can observe here the whatever the sharp corner, and it is doing the deburring. And also you can see with the full base of the machine, and it is possible to see with the full base of the machine. Okay, then I will pause here for any questions, or we will take some 5 minutes break, and then we will continue on to the 12 o'clock. That is fine for everyone. Or if you have any questions, you can chat me on the chat window. I will just try to answer your question. Break. Okay. In the chat, I can see some of the people they're asking how to do the custom tool from the 3D model, or maybe something like imported from the POM tools. Okay, I can see on the turning we have options called as a custom tools. The whenever you are creating here the options to select the custom tools to creating any kind of new tools, then you can able to select here the inserts called as the custom, and you can able to select the custom dimensions. Then you mention as your the custom drawing available. That much I can able to see on here. Maybe I can further I can see the how to import the 3D model or something you're asking that I need to cross check. Maybe I will get back to you on that questions. Presently, I'll just going to continue on to the what we are covering on that one. Okay, I hope you I have answered your questions. I will just stop my video. Okay, from next going to the PPT, and this is the drilling automations, the how to simplify for the drilling automation instead of only using the base drilling options like for to the manual drilling method. The what advantage we are having for to the automated drilling methods. Switching back to the software, just go into the options like whenever we are doing for to the drilling or like go to the drilling options. We are having two options. One is automated drilling and as well as the hole recognition and manual drilling. Suppose I'll use for to the manual like a drill options, and we need to choose the each and every the hole, or maybe you can define, but you cannot able to define the operations like first you want to do the spot and drill and other. This is the normal the procedure what the drilling method for to the manual, but we need to save our time. Whenever the number of holes are there, you cannot pick manually each, and you cannot identify the operations and all. Like we have the very special options for to the hole recognition. Just to click onto the hole recognition, it is coming under. Once you click onto the hole recognition, and it can able to identify here the option like these are all the holes is available on this particular model, like a 6.3, what is the blue color you are highlighted, and 5.1 is for this hole, and this is the ignore holes is more than the bigger diameter, that's why it is taken as a ignore. But still you want to set any operations, you can set it. Suppose I want to select this both, and I can say alternate selections. Now you can see all the holes are selected. These are all the holes. Suppose you want to change the each operations, like you want to spot drill and drill hole. You want to define your the operations, like you want to do the spot drill, tap and through hole or something, or you want to do the rim hole, the whatever operation. The suppose it is having any threading in the model, it will automatically recognize as a tapping onto the model, and it will do the tapping tool path also for that particular hole. Uh, this is very the simplified process method, and it is very quickly you can select the all the holes, and also you can see with the counter bore. Suppose it is an a counter bore for this hole, and it will do the spot drill and drill, then the counter bore hole. So the counter bore will create a separate toolpath for to the interpolation for this counter bore, and it will generate the toolpath. And also you can see the bottom, whenever you are selecting the hole, and you can see in the side the preview, the which is the counter bore hole, or it is in a plain hole, or the whatever the holes, you can able to see it. Okay, once you select, and it is just a click press, it automatically the recognized hole is 14 and the whole machine is 12, because of it is going to ignore these two holes, and also it will show you the result, how many holes are going to do it. Okay, once you click this one, and it will generate the tool path for this particular holes. Now you can see these are all the hole. The first the tool path was created with the uh, hole with the all the holes. Like the first one is the drill like a spotting tool path, and also you can see the rapid distance, and also you can see the operations, the retraction and all, and the operations what you are going to select. And the second tool path was this one, like it is doing the drilling for to the through and through. And also you can change the operation. Suppose you want to change the retraction and other, or you want to top up the hole, you want to start, or you where you want to stop, that all it is possible to stop it. And also it is in a selected method that you want to circles, and to the order for the optimization. This all possible to change when you are after creation. Also it is possible to modify it. And next one is doing the counter pour. You can see this is the milling operations. I selected the 8 mm diameter. It is a 12 mm diameter, and it is created the up to that depth. It is created the operations for that particular one. Okay, once you done, then the another two holes. These are the outer. It is in a spotting holes. Then it is in a drilling. The up to bottom depth was created. And also you can select the coolant type, and all it is speed is taken as per the material is selected when the setup was created. And the another two holes. It is in a spotting for this, and this is for this is the automated created hole for the whatever the hole. And also it is not only for the single hole, it is the multiple paces. Suppose I will just brief you the what the advantage on this. Like it is in a simplify the speed up the drilling, then automatically recognize the hole in the any plane or any pace. Okay, any plane on the any pair, like the it will automatically create for the side as well as the top and whatever, and automatically choose the tool the according to the tool diameter, the spotting and free drill and drilling. It will decide, and it will select the tool, then automatically order the operations. Like it is to avoid the minimum tool changing operations, then it will automatically avoid the like it is save your time for ordering of the tool path. Okay, and this you understand for the whole. Then the toolpath editing. Let us see understand the what capable it can do on the Fusion for to the toolpath editing. Okay, let us see the advantage when you are use the toolpath editing or the modification of the toolpath. The automatically or flexibly the toolpath modification, the wherever you want to the like toolpath trimming or deleting, that is going to help you onto the flexibly of the toolpath. Then the toolpath modification store onto the timeline, the wherever you've done the modification of toolpath, it is going to store on that particular toolpath whenever recalculating, and whenever you are recalculating, and it is going to do the machining or the do the toolpath calculations as per the thing. And must will be parallel to the pace, like it is wherever you want to plane or to the polygon or rectangular, and it is possible to trim along with the boundary. Several options are available. And also it is help you to the move the lead and links, the whenever the toolpath is trimming, you want to move or the toward the avoid the clamp or to the manual polishing, that is the help you for to the toolpath extension or the deleting of the toolpath. Okay, this is a strategy it will support for all the toolpath, like a move start point or delete or trim, the it will support for all the toolpath modification and store to the timeline that I can do it. And let us see the project, the how the toolpath trimming will help you on that in the especially for the Fusion. Okay, we will take one of the example. This is the project. You can see now. Uh, I have created the toolpath for this particular the area, or maybe this particular uh, toolpath. You can see the toolpath was calculated. This is the option where we can see in the toolpath. In the toolpath, trim, delete, replace tool, and move to the entry pass. These are the four options are available, and also you can see the icon. The first one is the limiting of the toolpath. Suppose you are taking the a toolpath, you want to trim or you want to trim it onto this particular plane or polygon or the boundary. Suppose I will select the plane. Suppose I need to draw the plane. Suppose I want to trim this toolpath, or you want to save inner, outer, or both. Just I will use as a inner. Now my toolpath is going to save only the inner of the this profile. Okay, that is the advantage of the when the toolpath was deleting or something you want to trim or delete. This one is help you for to the, you can see now my toolpath was saved only the inner of this profile. The what are the options I have used? It is trimmed outside and it is left out. I will keep both, then it will give you the both the option, and only you can run this toolpath as you require to machine it. Switch up the stock and you can see now, and it is machining only for that particular. Okay. Apart from the deleting of the toolpath, then you want to delete some passes. It is possible to delete the passes. Just you select. Suppose you don't want require some of the passes here, just you simply select it, and you can just simply delete it. This is the deleting options as the stronger as the what you see onto the other cam, and it is possible to um, delete it the toolpath, the whatever the toolpath or the complete toolpath you want to delete, and it will automatically recalculate. Now we can say this is the delete process was taken and it was recalculated. Okay. After this, then in the limiting, like replacing of the tool, after calculation of the tool path, you want to replace your tool using to the replace of the tool. Just to select and you can change your tool the according to the, then it will generate the tool path according to the tool what changes. Okay, apart from that, suppose I want to generate the toolpath on that particular only this areas, and you can see just simply select the boundary and it is possible to select, and also you want to delete some of the passes, just to simply select and you can able to delete it, and you can see the how the quickly you can able to generate the toolpath for the steep and shallow. You can use it, or I want to generate the toolpath only for the flat area, and you can see now it is possible to generate with the flat areas. Okay, this is the options called as the flat finish. It will generate only toolpath for the flat area. The apart from the steep and shallow where you want to run, this is the toolpath will generate only for the flat. Like the many options are there for the finishing strategy. As per the 3D model, you can able to generate the toolpath for to the finishing. Okay, this is the toolpath deleting having the and move start point. Also, it is any good options to suppose I have generated the toolpath. I want to move the start point. Now you can see my the all the start point has taken from this point. Now you want to move the start point using the move start point option. Now I will say from here to here I want to move. What will happen? My inside of this start point and it will move into the this. Now it will take all the start point, the toolpath entry will take on this particular line. Next is recalculating the toolpath. And now we can see it is moved the start point instead of moving here, and it is moved into here. Like this, the close toolpath segment can change the start point of your toolpath. Okay, and this is the next options for the inspection. Like how the extension can help you for the inspection. The only the base fusion can support only work coordinate settings. The others can support for this one. Okay, what is the probe geometry? Like measuring the future in the process with the probe cycles on your machines and verify the dimension. Like this is called as on machine verification. Before the unloading the job, it is possible to measure it onto the verifying your dimension on the critical feature before unloading your job, and update the tool where the parameter. Suppose the any tool where is there your dimension is not achieving, you want to update your tool where onto the controller. It is possible to also you can now pause and stop your programs because of the dimension is not achieving. You want to modify your programming, that will help you part to the um, And this is also the having it what I explained. These are all the one picture is coming into the base, and another three like a probe geometry, surface inspection, and part alignment with the report, and everything is coming onto the inspection onto the extension. And the surface inspection is create the probe part to the evaluate the result the after the importing or the measuring of your result, and it is possible to verify with the CAD model and the manufactured model, and you can generate the report with intolerance or the out of tolerance. They ensure the part meet design to the specification using to the machine verification. Then identify the problem area and to the decide for the rework if needed the before unloading your job. Now, minimize the or need to move the part between to the machine to the separate measuring devices. Like the after the machining, you want to move the this part into the different measuring devices like a CNC, CMM, or the portable, or you want to avoid the ensure the part to be machined properly before unloading the job. Okay, let us see the how it will help you on that one onto the technical demo. This is the part where you can see it, and once you milling here you can see the turning and additive and the inspection. Once you click onto the inspection, these are all options are able to see it in the inspection, especially for this the inspection like a probe inspection and the probe geometry surface inspection. These three is as it is now available as a part alignment and live. Like it is an possible to inspect the live also. The that is options is available onto the uh, live connection. You can connect your the PC or the software onto the particularly live machine. Presently, we are successfully completed with the HAAS machines. When you are doing in the HAAS demo day, that is the live inspection. We have measured onto the connecting with the machine with the cable or maybe the Wi-Fi connection. This can able to connect with the live inspect, and it's possible to measure using the live like the where the tool is moving. Then the software also it is possible to identify that point is correct or any the material is removed more or it is less. Okay, that is possible to connect it like that is called as live connection. Then the import the inspection report. The after measuring you want to import, I'll explain later this one. Okay, now first one is probe setup. Once you done the probe setup, then you can go for to the probe geometry, the wherever you want to inspect for using the probe geometry, like you want to inspect for this particular things, and you can just select and you can see the how the probing tool path was created, and possible to see here the touching onto the pore point, and it is going back and it is generated the probe point paths. Okay, once you done, and also it is possible to probe geometry and as well as the surface inspection. Surface inspection basically you want to do the inspection on this particular point, just simply clicking on this particular point, and you need to measure it or something. Just you need to measure on this particular height or maybe the dimensions. This possible to measure on this particular. Once you've done, then you click OK. And also it is possible to enter some of the parameters like the safe distance, another, and the tool. Especially you need to mention the proper tool. Here having a probe tool, the 6 mm diameter and 3 mm shank that we need to mention as per the probe, like Erenis or to the Morphos or any other kind. Once you've done, then you click OK. You want to see the simulation, just you right click and simulation start. And now it is going to the measure the wherever the point I have given that one. You want to increase, you can increase the speed. Okay. Once you've done this inspection, then you send this NC program into particularly onto the machine, or maybe it is in a live inspection, then it will automatically you can send through the LAN or the maybe the pen drive, and you can measure it. Once you measure, then it is coming into the like import the inspection result. Once you click and it is possible to import or the select the resulted file. Just you select the resulted file, and it is going to give you the exact difference between the then after it, yeah, it is possible to generate the report like it is in a setup sheet. It is possible to inspection report, and this is a setup sheet for to the measuring, then the inspection report, and it will going to give you the inspection report on that particular things. Okay, on this all the options like a probing, and these are all the live inspections, and these are the manual inspection. You want to create the manual inspection, and can measure it as you require. Okay, any doubts or any questions before moving into the PPT? You have any questions, you can chat me on the window. Maybe I can take it on there. Okay, I think you understand the today agenda of the manufacturing extension to covering all of the options, like a start with for to the steep and shallow, then the 4-axis, then automatic 2-axis alignment, that all we have covered. Then also we were covered for to the drilling, then the inspection. These are the major the options on to the extension, and the how the our customers are using and what are the problems they are facing. These are some of the customer success story for to the like the problem improved, like what a problem they are facing to improve the efficiency of the machining strategy, or to the multiple tools to import design and the program part for present they are facing the problem. But with help of the Fusion 360, they are find like improve the cycle time, then the adaptive clearance using the to maintaining the large continuously engaging the tool or thing. And also it is consolidating to the multiple tools to integrate with the one CAD CAM solutions. That is the Fusion 360 they are using for to the end-to-end solutions. This is having a some of the design strategy onto the machine. They can come down into the 1 hour, because of before they are doing into the machining is a lot of time. Another customer success story, like they are using the 8 different software to program for their product development and processing. The spending 1 hour to generating the CAM toolpath. Then the continuity between the CAD to CAM workflow. It is costly to rework whenever the design is not updating it properly into the shop floor. This is the advantage when they're considering to the 8 software, they cannot into the one software to design, to assemble, and as well as the manufacturing. Now can this Fusion 360 can run in the Mac systems. Then also cut the CAM toolpath to calculate the hours to the few minutes, because of before taking to the hour plus to calculate the toolpath. Then it is an eliminated the rework because of an integrated CAD CAM software. Then the customer feedback is like a Fusion 360 is first class software, it is having a cloud based software, and also you can see the project anywhere and all the things they can get benefited. Okay, this is as of now today. I hope you learn some of the new features and the new capability on the Fusion 360, the how it will support for extension and the base. Maybe after these sections, we the everyone the partner need to practice this part, and we maybe the some time we will give the gap. Then you have to give the pitch back section from the particular that we will discuss, and especially first we need to understand the features of the extension and what is the advantage for to this particular. And thanks for everyone to spending their time with this. I hope from this classes or from this workshop you got some of the idea, the Fusion 360, you learn something new on that one. Hope of that one. Any questions or anything, let me know. We will take the questions and maybe I'll try to answer your questions. Having a one question is how to import the tool model from to the phase group operations in the turning. Pay screw, like I need to cross check the what kind of model. Maybe you can send me. I will cross check. And I will give the solution for that particular the 3D model you have. You can send me. I will try to give the solution on that one. I hope I have answered your question. Because if I need to understand your 3D model, then maybe I can try to give the solution on that particular. If you have any questions, anything, maybe you can unmute yourself and you can ask me questions, or maybe you can chat me on the chat window. Surya, anything you want to add?